Somewhere in the vast darkness of space, a telescope built to answer our oldest questions has instead raised ones we never thought to ask. The James Webb Space Telescope, the most powerful eye humanity has ever pointed at the sky, has sent back data so strange, so deeply unsettling, that a Nobel Prize-winning physicist felt compelled to speak out. His message was short, chilling, impossible to ignore. He said, "This is not our universe." So what exactly did Webb find out there at the edge of everything? And why are the world's brightest minds quietly starting to panic? Picture a tiny yellow smudge in a corner of the sky, easy to overlook, forgettable even. But when astronomers trained their instruments on it, their confidence shattered. That smudge was a galaxy, the most distant ever recorded, blazing into existence just 290 million years after the supposed birth of the universe. And here's where the story breaks. It's too big, too bright, too fully formed. According to everything we know about cosmic evolution, a galaxy like this simply had no business existing that early. There wasn't enough time. There wasn't enough matter. And yet there it is. And it brought friends. Webb has since found dozens more just like it, each one a quiet, glowing contradiction of everything we thought we knew. Scientists dove deeper, expecting answers. What they found instead was something far stranger. Among these early universe giants, at least 3 galaxies appear to have converted every single particle of their gas into stars. Not 10%, the usual rate. Not 50, 100. Nothing left behind. No dust, no raw material, just wall-to-wall blazing starlight. Every model of galaxy formation says this is impossible. So physicists are now asking a question that would have seemed absurd just 5 years ago. What if these aren't galaxies at all? What if we're not looking at the early universe, but at something else entirely? To understand why that question is so explosive, you need to understand something called the Hubble sphere. As the universe expands, distant galaxies move away from us, and the farther they are, the faster they recede. At a certain boundary, they're moving away faster than light itself. Logic says we should never see them. And yet, Webb is picking up light from beyond that boundary. Light that by every rule we have should never have reached us. Which leads to a conclusion that keeps cosmologists awake at night. We may be seeing beyond the edge of our own universe. And nobody knows what's on the other side. That realization has cracked something open in the scientific community. Nobel laureates, people who built their careers on the Big Bang model, are now openly questioning it. Because if galaxies form faster than physics permits, if light crosses boundaries it cannot cross, if structures appear that defy time and mass and scale, then maybe we haven't misread a few equations. Maybe we've misread everything. Maybe what we're calling the early universe isn't early at all. Maybe it's a fracture, a seam where 2 realities press against each other and something ancient is bleeding through. But the visual discoveries are only part of the story. Because among Webb's most quietly disturbing findings isn't an image at all. It's a sound, a frequency. While scanning the background noise of the cosmos, Webb's instruments picked up a faint, rhythmic oscillation that matches nothing in our catalogue of known phenomena. Not a pulsar, not gravitational waves, not any variation of the cosmic microwave background. It repeats at precise, regular intervals, almost like a signal. Some astrophysicists have taken to calling it the heartbeat. Beyond time, others suggest it could be a signature of exotic matter existing outside the walls of our universe. And the detail that refuses to leave you alone? The pattern is mathematical, structured, as if it was placed there to be found. Alongside that eerie frequency, Webb is detecting something else, gravity with no source. Galaxies at the farthest reaches of the observable universe are bending light, warping space, influencing surrounding structures. And yet when astronomers look for the matter responsible, there's nothing there. This goes beyond dark matter, which at least fits our existing frameworks. These are gravitational anomalies with no known origin, phantom forces pressing down on the fabric of space-time from somewhere we cannot see. Some theorists have arrived at a staggering hypothesis. We may be feeling the gravitational shadow of another universe, physically colliding with our own. And if that isn't enough, Webb has also captured something in the rotational patterns of distant galaxies, an asymmetry that shouldn't exist. A cosmic lopsidedness, as if two different systems with two different sets of rules are overlapping in the same space. A once dismissed theory is suddenly looking less fringe. The idea that a mirror universe exists alongside our own, where time runs backward and physics operates in reverse. What Webb may be seeing are the fingerprints of that collision. Two realities, moving in opposite directions, tangled together at the edges. Then came the echo. One of Webb's instruments was tracking a light signature from the very rim of the observable universe, fully expecting it to fade and vanish as distant light always does. Instead, it came back, not from the same direction, not at the same moment, but carrying the exact same spectral fingerprint, as if the light had been sent out, hit something, and bounced home. There are only two explanations. Either space is finite and curved, and the light looped all the way around, or something is out there at the edge, something large enough, solid enough, to reflect light back across the universe. Something that has absolutely no place in our current understanding of reality. Webb was built to look backward in time, to find the universe's beginning and make sense of how we got here. Instead, it may have done something far more profound and far more terrifying. It may have found the walls, the impossible galaxies, the phantom gravity, the mirrored patterns, the rhythmic pulse, the returning echo, taken individually, each one is a mystery. Taken together, they form a picture that one Nobel laureate has already put into words. This is not our universe, and perhaps that's the truth we built all our telescopes specifically to avoid, that we are not the whole story. That beyond everything we can see, touch, or measure, there is something older, something vaster, something that doesn't know we exist and never will. The real question was never whether we're alone in the cosmos. It's whether we're even in the right one.